Hi, 6th graders, this is Mrs. Gall. Today we're going to talk through perimeter and area. Our main emphasis is on area, but we do have some things to cover that are new with perimeter. Open up your notes and title this perimeter and area at the top of your page. Press play when you're ready to continue. If at any time I'm moving too quickly and you need to pause the video to write something down, please do. Let's get started with our definition for perimeter. Perimeter is the distance around a two-dimensional figure. If I think about a backyard that has a fence, say that's my fence, the distance around that fence would be our perimeter. The perimeter of a circle has a special name. It's called the circumference. Perimeter is one-dimensional. We're only measuring the length. So when we write the units, we just write the units without any squaring or cubing. So it's just written as units. Let's continue on. Let's practice finding perimeter. To find perimeter of a triangle, we're going to add up all three sides. So on your calculator, we're going to add 12 and a half plus 12.8. Did I say 12 and a half? I meant 28 and a half if I said 12 and a half earlier. And 17. Let's go ahead and add those on our calculators. I'm getting 58.3 centimeters for that perimeter. Let's try a quadrilateral. Here's a rectangle. Sometimes you have to use your knowledge about rectangles to help you with any missing side lengths. So on this rectangle, you can see we were given 8 and 3. So for a rectangle's perimeter, we want to add up all 4 sides. What are these two missing sides? Well, they're the same as the sides that they are parallel to. So that one is 8, that one is 3. Let's add up all 4 sides. I'll give you a moment to do so. 8 plus 3 is 11, plus 8 plus 3, which is also 11. So altogether, that's 22 centimeters for this perimeter. Let's continue on. Now let's find circumference. In order to find circumference, you need to know the formula. There are 2 formulas that we can use. Pi times diameter. Diameter is the distance all the way across a circle. Or, if you're given the radius, which is half of the diameter, you can take 2 pi r, which doubles your radius for you to give you the diameter. So let's look at our first circle. We were given the distance all the way across the diameter, so let's use this top formula. All we need to do is plug in 12 inches where that d is in our formula. So c equals pi times 12. On my calculator, I'm going to use the pi button so I get as accurate of an answer as possible. When I plug in pi times 12, my circumference is totaling 37. It looks like it's 0.699 and the decimal continues on, so I'm just going to round that to 37.7 inches. Let's look at another example. In this example, we're given the radius. It's halfway across the circle, so this might be a better chance to use our second formula, 2 pi r. So where the r is at, I'm going to replace that with a 7.1 and plug that into my calculator. 2 times pi times 7.1. I'm getting a long decimal, which we can round to the nearest tenth, 44.6 meters. Let's continue on to area. Area is the amount of space contained by the boundaries of a 2D figure. Earlier when we were talking about the fence being around the backyard and you can measure that distance around, well, if you think about the grass that fills up this backyard, that would be the area, the space inside those boundaries. Area is measuring length and width, so it must always be written as units squared. How are perimeter and area related? With perimeter, we're looking at the distance around a 2D figure. With area, we can look at that same exact figure and just look at what is in that space inside the line that created the perimeter. Let's try finding area of this parallelogram. The formula for area is base times height. Let's start with this rectangle. My base is 75, my height is 45. So if I plug those values into my formula, I have 75 times 45. Grab your calculator to see if we get the same thing. I'm getting 3,375. My units would be meters squared since I'm working with area. Let's move on to area of a triangle. This formula is half of the base times height because a triangle takes up half the space that those quadrilaterals will. So we're going to take the same process of base times height, but make sure we multiply it by a half, which could be 0.5 on a calculator, or just divide by 2 after you multiply the base and the height. How do you know what the base and the height are on this triangle? It's a really great question. Your base and your height will always create a 90-degree angle on your triangle. So I can see the 90-degree angle down here, this perfect box, and the two lines that make that 90-degree angle are my 6 and my 16. So that's my base and that's my height. The 10s will not get used for this area formula. Let's plug those in. We have half times 16 times 6. Like I said, on a calculator, you can plug in half by typing 0.5 times 16 times 6. I got 48 feet squared. Or you can also take 16 times 6 and then divide by 2. That will also give you half. Let's move on to area of a trapezoid. Area of a trapezoid has a little bit more of a complex formula. It's half of the height times base 1 plus base 2, because trapezoids have bases that are generally different lengths. Here's an example. My bases on a trapezoid are my two lines that run parallel to each other, 8 and 20. So let's plug those in as base 1 and base 2. The height of the trapezoid is the distance between the two bases, which is going to be that line that creates that 90-degree angle, not a slanted line. So that is 8. So we're going to take half of 8 and times that by 8 plus 20. Half times 8, I know that's going to give me 4. And then I'm going to times that by 8 plus 20, which is 28. I can kind of do that mentally if I want. So it's going to end up being 4 times 28. I'm getting 100. Oh, that's too high. Let me redo that. 4 times 28. Yeah, that's right. I'm getting 112. And that would be kilometers squared. So again, your base 1 and base 2, you add together your parallel lines, then you times that by half of the base, or half of the height, which is the distance between the bases. Let's try another one. If you want to pause and try on your own, you can. If you want to work with me, you can keep the video playing. Let's plug in our two bases, our lines that are parallel. That's 9 and 2. So those get added together because that's what the formula says to add our bases. And then we're going to times that by half of the height, which was 6, the distance between the lines. So I know half of 6 is 3. 9 plus 2 is 11. 3 times 11 is 33 kilometers squared. Let's move on to area of a circle. Area of a circle has the formula pi r squared. You will definitely want a calculator for this since pi is involved. Radius is halfway through our circle, so sometimes they'll give you diameter and you have to identify what the radius is. On this example, they're giving you radius 8. So we're just going to replace the r with an 8 and plug that into our calculator to solve. Pi times 8 squared. You can use the caret button to square something, or there is an x squared that allows you to just square a number. When I plug that into my calculator, I'm getting 201.06, so I'll round that to 201.1 inches squared. This is the diameter. How would we figure out the radius? Radius is half of the diameter, so half of 5 would be 2.5 centimeters. So we want to plug a 2.5 into our formula. Pi times 2.5 squared. Solve for that now, see if we get the same thing. 19.63, so I'm going to round that to 19.6 centimeters squared. My last type of skill is area of composite figures. This is when we merge two figures together and have to find the total figure's area. You're going to want to draw lines to help you separate these into shapes that we're already familiar with finding area of. For example, on this composite figure, I could draw a horizontal line, and now I have a square and a rectangle that I'm pretty confident with finding area of. Square's area is base times height, 8 times 8, which gives us 64 yards squared. Rectangle is also base times height, 16 times 4, which is also 64 yards squared. So how do I get that total figure's area? I add those together. 64 plus 64 gives us 128 yards squared for that entire figure's area. This one gets a little bit tricky. I have a couple of places I could draw lines. I could draw a vertical line here or a horizontal line here. I'm going to choose the horizontal line. We have a little bit of problem solving to do. We now have a rectangle at the bottom and a trapezoid at the top. Let's start with the rectangle. Rectangle's formula is base times height, which is 12 times 6. That gives us 72. Trapezoid, base plus base, base 1 plus base 2 times half of the height. Let's plug those in, figure out what those different values are. This is one base, 8. Down here's another base. What must this line be? The same as this line, 12. So there's my two bases. Now we need to figure out the height of the trapezoid. It's not 13. 13 is this entire line. How can we figure out just this line? Well, on this other side, we know this bottom piece on the rectangle is 6. So this entire side is 13. If the rectangle has a side length of 6, the trapezoid must have a height of 7 because we have to get up to 13. So that's our height. I know half of 7 is 3.5, and 8 plus 12 is 20. So I'm going to plug that into my calculator, 3.5 times 20, to get 70 for the trapezoid. 70 plus 72 gives us our total area, 142 inches squared. One more for you today. It's a house pentagon shape. I would split this in half to create a triangle and a rectangle. If you want to try this one on your own, go for it. If you want to go through with me, continue listening. My rectangle has area, length and width of 6 and 5. I multiply those together to get 30 inches squared. My triangle, That's going to be base times height, but remember we have to take half of the base times height. So divide by 2, or just do half times base times height. The base of my triangle is the same as the bottom of the rectangle, 6. The height of my triangle is indicated off to the side here, 3. I know 6 times 3 is 18, and half of 18 is 9. So this top piece is 9 inches squared. Altogether, 9 plus 39 gives this figure's area a total of 39 inches squared. You guys, that's all I have for you today with composite figures. Check in with your teacher if you have any questions.